Hello students, welcome to my channel The Field of Chemistry. I am Vijay Lakshmi. Today we are going to discuss about the physical properties of amine. Last class we have discussed about the properties of amines, which are the reactions of amines, how to prepare the amines, that and all we have seen. Now in this session, we are going to discuss about what are the properties, what are the characters, all those things we are going to discuss. In that, primary, secondary, tertiary amine, already I have explained you in the starting classes only. So, primary amine means in that ammonia, what is the formula? NH3. In that ammonia, one hydrogen is replaced by alkyl group. So that means this is a primary amine. Instead of hydrogen, one alkyl group is there. It is a primary amine. Instead of two hydrogen, two alkyl groups are there. So it is a secondary amine. Instead of three hydrogens, three alkyl groups are there. So it is a tertiary amine. Okay. Next point. Lower aliphatic amines of fishy order. Lower aliphatic amines means primary, secondary, tertiary also included. Now, they are soluble in water. Usually, wherever hydrogen bond is available, those compounds are soluble in water. Why? Because they have hydrogen bond. It is connected with, it's bonded with that hydrogen. So, hydrogen bond, it's connected with water molecules. So, naturally, it will be soluble in water. Remember this point. Why amines are soluble in water? Because of the hydrogen bond connected in that with the water molecule. Okay, now higher amines means, for example, aniline, benzenamine. Okay, higher amines are insoluble in water due to the size of hydrophobic group. Okay, now next one. Oxygen is more electronegative than nitrogen. You know very well oxygen. Oxygen is more electronegative than nitrogen atom. Hence, amines are less soluble in polar solvents like water and corresponding alcohol. Hope you got this point. See, amines are less soluble in polar solvent. Which is polar solvent here? Water is a polar solvent. Corresponding alcohol. Okay. Now, next question wise, like give reason question wise, I would like to explain some points in this in this video. Okay, now why tertiary amines are less soluble in water? See, primary amines, secondary amines are easily soluble, but tertiary amines, it will not soluble. Just now I have told all those lower aliphatic amines are soluble in water. That is because of hydrogen bond in it. Okay, but in tertiary amines, there is no hydrogen bond. Hydrogen bond is replaced by alkyl group. That is the main reason. Only primary and secondary amines contain hydrogen atom. Of course, here hydrogen atom is there. They can form hydrogen bonds with water, and increase the solubility. But tertiary amine do not have hydrogen bond in the formation of water. Okay, so it will not be soluble in water. Hope you got it. Here there is no hydrogen bond, but in for primary and secondary there is a hydrogen bond. So naturally, wherever hydrogen bond is available, that will be soluble in water. But where there is no hydrogen bond, it will not be soluble in water. Got it? Why tertiary amines are less soluble in water? Due to the hydrogen atom less. That means tertiary amine do not have hydrogen bond in it. Okay, got it? Next one. Next question is, why primary amines are more boiling point? Even this also, even aldehydes, ketones, why aldehydes are more boiling point? Like such kind of questions we have seen. Here also the same question repeated, like why? Give reason. Always it will be better 2 mark question, 1 mark question. Choose the correct answer. Multiple MCQs everywhere you can ask. One thing I'll tell you, IIT JEE questions and all, directly they will not ask that concept. They will ask through the question. Suppose if you know the concept only, you are able to answer in the question. So better you should know the concept very well, then you can learn for that IIT JEE exams. Okay, now concept, it's very very important. Why I'm telling many times repeated way, because conceptual questions only they are asking IIT JEE questions, so you should know very well the concept. Come to the point, why primary amines are having more boiling point. Naturally hydrogen bond is there. Okay, in primary amine, this is the primary amine just now I mentioned here. Primary amine, two hydrogen atom have maximum intermolecular hydrogen bonding, hence they have maximum boiling point. So hydrogen bond is there, that intermolecular space, the hydrogen bonding, it is available. In order of the boiling point, here they have given primary amines are having higher boiling point than the secondary amine, tertiary amine. Why what it is? Tertiary amines are having less boiling point because there is no hydrogen atom. This also you can give the answer. Okay, next one, in order to boiling point isomeric amines, here they have given the formula in such a way. You just check it. See here, C4H9NH2. So if you are writing in this formula CH3, CH2, 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 NH2. So this is one formula. The same way C2H5 twice NH. That means what it is? Here ethanamine, N-ethyl ethanamine. Then next one, C2H5N CH3 twice. That means this is tertiary. So here what it is? C2H5 C2H5 twice. Okay, now here what it is? This also what it is? Ethanamine, NN diethyl ethanamine. Here butanamine, butane, 1, 2, 3, 4 carbons are there, naturally butanamine. So all these molecular mass is 73 only. When you are going to boiling point, it varies according to that. See, this is a primary amine. CH2, NH2. NH2 it is there, means naturally it is a primary amine. So what is that? 350.8. Then here the secondary, here this is the primary amine, here this is the secondary amine. Secondary amine, both two hydrogens replaced by two alkyl group. So here 329.3. Comparatively this is less. Okay, next third one, this is tertiary. 3 hydrogen is completely replaced by alkyl group. So here what it is? Same molecular mass but different boiling point, because here primary amine is having higher maximum number of hydrogen atom. Okay, that is what boiling point also higher. MCQ point they may ask all these things. Okay, hope you got it. Basic character of amines. Now when we are talking about basic character of amines, means here it comes from ammonia derivatives. Ammonia actually it's a basic compound. Okay, from here amines are derived, so that it is naturally basic character it is available. Amines are having unshared pair of electron. Where it is unshared pair of electron? Here nitrogen is there. Nitrogen in that ammonia, those 3 hydrogens are replaced by 3 alkyl groups. You got it? Here 3 hydrogens are replaced by 3 hydrogen groups. Here 2 lone pair, that means electrons, unshared pair of electrons are available. So that is lone pair of electrons. 2 electrons are there, which is unshareable. Okay, so here, so this is a basic nature of amine. A lone pair of electron is having a 1 plus point of basic nature. Okay, lone pair of electrons are capable of donating electrons. Remember that always whenever what it is, extra electrons, that means which is extra outside of orbital, if there is anything extra that is ready to donate the electrons. Okay, when it is ready to donate electrons, naturally it acts as a Lewis base. Lewis base is what it is, ready to donate electrons. See here what it is, NH2. Here 2 what it is, lone pair of electrons are there, and then HCl, here Cl minus here. So what happened here? from here lone pair it's going to give, ready to give. So naturally it become a salt. What it is? RNH3 plus Cl minus. Okay, basic nature of amine in Kb, pKb values. They may ask that question. Explain about the basic nature of amine in Kb and pKb. First of all, what is the meaning of Kb and pKb? Understanding the point of Kb and pKb, Kb values indicates the high level of dissociation of strong base. So here K, it's a constant value, and B for base actually. Here Kb value indicates higher level of dissociation of electrons. That means completely soluble, completely ions are mingled in that solution. Dissociation of a base. So pKb, here what is that interrelation about pKb? pKb value indicates the stronger base. So what it is? How many ions are completely dissociated in the strong base? pKb value indicates that strong base. Okay, now pKa and pKb by the simple relation of pKa plus pKb equal to 14. So naturally if you get that answer 14 means what it will be here? Ka and Kb, it is nothing. Now what it is? Acid and base combined together. It is a neutralized salt and water. Okay, so this is 14. Hope you got that point of Ka and pKa, Kb and pKb. Kb is nothing, dissociation of ions in the strong base. pKb is nothing, indicates the strong base. Okay, this is which is a strong base. We are going to decide which is a strong base, whether it is ammonia it is a strong base or amine it is a strong base, that we are going to discuss. Okay, now here basic nature of amine pKa and Kb, pKb and Kb, it is amines also accepts the proton from water. Okay, hence it acts as a Bronsted-Lowry's base. It is actually, see, it combined with water. So when we are going to the water, dissociation of electrons, H plus OH minus. So when the bond goes this side, naturally this is plus and this is minus. Always whenever the bond goes upwards or next to that point, naturally that means electrons are ready to give, so it will get minus. Where electrons are going away, here you will get the plus point. Okay, remember that. Now this plus charge is attracted from the lone pair of electrons. So what happened here are NH3 plus OH minus, here OH minus. Now equilibrium, we have to write it. Equilibrium for the above equation, Kb equal to reactant by product. Which is a reactant? This side it's a reactant and this side it's a product. Okay, now let us write that equilibrium step. See, Kb equal to reactant by product. So reactant, it is what it is? Sorry, Kb equal to product by reactant according to the equilibrium. That only is the concept. Sorry, I meant wrong. Okay, Kb equal to product by reactant. So product, what it is here, are NH3 plus OH minus. This is a product, and divided by the reactant, what it is there, this one. Okay, now we are going to check the Kb of water molecule. Okay, so concentration of water molecule. Okay, now what happened here? The same way, if you get this side, now what happened? You just write as it is, or NH3 plus the concentration into OH minus concentration divided by R NH3. Okay, here NH2 concentration. You just bring as it is, only water it is removed from here. Okay, now next one. See here, basicity constant Kb equal to RNH3 concentration, OH minus concentration divided by RNH2. Now what is the value of Kb? It is, Kb is the dissociation constant. Dissociation constant of amines. Here what is the value of amine? pKb. pKb always will be negative logarithm of Kb. This is the answer. So pKb is what it is? Negative logarithm of Kb. Okay, remember this point. pKb equal to minus log Kb. One short trick I'll tell you. Higher the value of Kb, lesser the value of pKb. That's what I mentioned here. pKb equal to minus log Kb. So here if it is higher means Kb will be lower. That's what minus sign. Okay. Now suppose Kb it is increasing, pKb it is decreasing. Okay. That's what higher the value of Kb, lesser the value of pKb. Maybe pKb it is higher means Kb will be lower. So that strong base, which is a strong base here. So see Kb here, this is one concept. Suppose MCQ questions comes means, see Kb increases, pKb decreases. That means what type of base it is? Strong base. Strong base. Okay, remember this. Kb it is increasing, pKb it is decreasing. That is actually strong base. You just consider this. This is tips I am giving. The same way what it is? Kb it is decreasing and pKb it is increasing. It is a weak base. Okay, remember these 2 points. MCQ questions they may ask. Okay, Kb value it is decreasing, or pKb value it is increasing, means naturally it is a weak base. Okay, remember these 2 points. Okay, now next one also we are going to discuss that give reason question. Here one more question we are going to discuss, which is very, very important. Why methyl amines are stronger than ammonia? Here aldehydes are stronger than ketone. Like such kind of questions we have seen. No, the same way, why methyl amines are stronger than ammonia? That's what, which is higher value, which is more stronger. In such a way we are going to get that question. So what is the answer? Now here ammonia, just ammonia we take it. In such a way I will write it hydrogen ammonia. This is the formula of ammonia, 2 lone pairs of electron, and it is connected with H plus Cl minus. That is, it is reacting with acid. Now what happened here? This lone pair of electrons which is attracted towards the H plus ions. Now what happened here? Ion formation. Here ammonium ion. See hydrogen, hydrogen, hydrogen. Here also hydrogen. Coordinate bond. You might have learnt in 11th standard coordination. Coordinate bond. Okay. Ionic bond and what it is? Covalent bond. Coordinate bond. That means giving together and it will stay in that. So that is coordinate. So this lone pair of electrons giving and connected with this. Okay. Now remember, ionic bond means it's completely given. A covalent bond means it's a sharing. But here coordinate bond, this is giving and keeping in themselves. So this is called what it is? Ammonium. Ammonium ion. Okay. Now ammonium ion, naturally it is losing, means you are getting a plus symbol. Always whenever it losing electron, naturally it gets plus symbol. Okay. Now next point here. For example, primary, this is a ammonia. This is called ammonia. Ammonia, when it's reacting with acid, you are getting ammonium ion. Now primary amine, so for example here N, here hydrogen, here two lone pair of electrons is available. In that connected with H plus ion. So what happens here? Here what it is? Primary amine. Primary amine. Okay, now here what happens? This also it is ready to donate electrons because of that what it is? Cl minus here. So because of the attraction of positive charge. Now what happened here? N or this side also hydrogen, just as it is you are bringing, this is plus sign. Okay, remember that. Now this is alkyl ammonium ion. What it is called? The alkyl ammonium ion. See, both are same, but which is strong base? Now we have to think. Okay, now see here, this is acid. Here, now this is actually alkyl group. Here this is a hydrogen bond. Okay, now alkyl group, first point, alkyl groups are electron releasing group. Do you remember in first 11th standard we have learnt? Okay, alkyl groups are electron releasing group. See here, when it is ready to release the electron, it's pushing the what it is, nitrogen. So when it is pushing, electron density will be higher in that nitrogen. So electron density is increasing. Naturally, it is ready to give electrons towards that H plus ions. But this also it is giving more than this. This alkyl groups are pushing the electrons towards the nitrogen. So nitrogen is getting that density higher. That is the reason it's ready to donate the electrons. So automatically you are getting alkyl ammonium, that is more stronger than ammonia. Here it is ready to donate the electrons because of the lone pair of electrons. But here alkyl groups, it's pushing the electrons. Then only it is getting more faster. That means alkyl amine, that is a primary amine, it's more stronger than ammonia. I'm coming to that point only. Alkyl group attached to the nitrogen, so the electron density on the nitrogen atom increases. So lone pair of electrons in nitrogen atom, it's easily donate the electrons to that H plus ions. That is the reason why amines, primary amines are stronger than ammonia. Hope you got it. In the same way, secondary amines also more stronger. You see here, secondary amine, I'll write it here R, here also R, here H. Okay, now lone pair of electrons I have written in such a way so that it will be easy for you. See here, N I have written, R, here R, here H. Lone pair of electrons here, H plus ion. It's ready to donate electrons because of that pushing of what it is. Two alkyl groups are there. Two alkyl groups are releasing electrons group. Okay, it's giving more pressure to the nitrogen. So naturally, what it is, density of nitrogen will be increasing. When the density of nitrogen it is increases, the electrons are pushing towards that hydrogen, that is positive ion. Then you will get what it is, dialkyl ammonium ion. Okay, here N, R, here R, here what it is, H, here H, here plus ion will be there. So dialkyl ammonium ion. Okay, now that next one. See, now tertiary also, but tertiary will be vary. Why? Because hydrogen bond in that place nil. Okay, I'm coming to that point. See, now tertiary amine, suppose if you take all three groups, three sides, what it is there? Alkyl groups are there. All three alkyl group, usually alkyl group, it is electron releasing group, plus I effect. Okay, it's ready to push the electron. All these three sides, it's pushing electrons. So naturally, these electrons are ready to donate electrons. It is what it is, the same way N, R, R, here also R, here H. So trialkyl ammonium ion. Okay, now here, now what is that ratio if we go for that, what it is, donating electrons, all those, which is ammonia is stronger or primary amines are stronger? Commonly, we are not mentioning whether primary amines are stronger, secondary amines are stronger, tertiary amines are stronger. We are telling about that amines are stronger than ammonia. See, now it is tertiary amines are stronger than, secondary amines are stronger than, primary amines are stronger than ammonia. So ammonia, when we are comparing, it is actually weak. Okay, that is the point we can, according to the stronger point. Okay, so amines are stronger. So NH2 or NH2 or RNH or RN, all those things, amines are stronger. Amines are stronger than ammonia. Remember that. Why? Because alkyl groups are plus I effect, which is electron releasing group, which is pushing the electrons, that donating the electron, ready to donate the electrons to the hydrogen atom. That is what it is. Amines are stronger. Hope you got it. Now next point what we are going to discuss, primary amines are stronger than ammonia. Last point what we have checked, amines are stronger than ammonia. In that, which is stronger? That means whether primary amine or secondary amine or tertiary amine, which is stronger? Means primary amines are stronger than ammonia. How? Presence of electron donating group on nitrogen, increasing the stability of cations formed after the donating of lone pair of electrons. See, now primary amine, I will write it here. Primary amine, here R, hydrogen, here hydrogen, lone pair of electrons. Here ammonia, H. See, in these two, it is ready to donate electrons. Okay, now here, see here actually, primary amines are ready to donate electrons because of that alkyl group, and what it is pushing the electrons. So naturally it is ready to give the electrons. But here lone pair of electrons are there, which is attracted by plus ion. So naturally it is going to give that. Okay, now here, due to the lone pair of electrons in nitrogen atom can be easily donated and make it as a strong base. So which is a strong base? Means here primary amines are stronger than ammonia, but when it is coming into the aqueous point, what it is aqueous? When it is soluble in water, when it is combined with that water molecule, that means aqueous solution, they do not follow this order. So which is greater? Primary amines are greater. That means primary amines are stronger than ammonia. Why primary amines are stronger? Because here alkyl groups are electron releasing group, which is pushing the electron atom. So it is ready to donate the electrons. So that is what primary amines are stronger than ammonia. But in aqueous solution, it will be varied in this order. Okay. See, finally, not only because of plus I effect, that means electron releasing group, because of alkyl releasing group, no, not only that, it is a solvation effect and steric hindrance also it will takes place. Solvation effect when it is soluble in water. Even in soluble in water, hydrogen bond is there, so it will be easily soluble in water. And then steric hindrance, alkyl groups are bulky group which is attached to the nitrogen atom. So that is also we can tell those points. Okay, so only alkyl groups are more stronger, that means it is electron releasing group, that is why it's pushing the nitrogen atom and those lone pair of electrons ready to donate. Not only that, even these points also we can say. Okay, next one here. Next point, see, first point what it is, whether amines or ammonia which is stronger. So naturally amines are stronger, that point we have proved. Second point, primary amines or ammonia, in that primary amines are stronger, that is also we proved. Here in this only they both got fight, whether it is a primary amines or secondary amines which is stronger. Okay, now in this actually here, see, in this number of alkyl groups we are going to check. Number of alkyl groups means more number of alkyl groups will be present in secondary amine, less number of alkyl groups present in primary amine. So more number of alkyl groups are ready to push the electron directly, it is attached to the nitrogen atom. So it is ready to push the electrons. When it is pushing the electrons, so automatically what happened, lone pair of electrons, it is ready to donate. So whenever whoever it is, if they are encouraging us, naturally we will go push forward. The same way here also, number of alkyl groups are more in secondary amine. So naturally what it is, alkyl groups are electron releasing groups, it's ready to push the nitrogen atom. So nitrogen atom in that lone pair ready to donate the electrons, but here number of alkyl group is less. But even though it is pushing, but number of alkyl groups are higher, in that only that will be stronger. So secondary amines are stronger than primary amine. Why? Because number of alkyl groups are more. Hope you got it. Okay, next question. Now, tertiary amines are weaker than primary and secondary. Why tertiary amines are weaker? It is actually, see here, this is primary amine, secondary amine, tertiary amine. Tertiary amines are bulky group, that is steric hindrance will be more. But here secondary amine only both the side, that means one hydrogen atom, it is ready to react with other molecule. But here very less, that means only one alkyl group is there. So primary amines are ready to put the net, that means it's ready to react with other molecules faster than the tertiary amine. Why tertiary amines are having what it is, more number of alkyl groups are there, which is bulky group and steric hindrance takes place. That is what tertiary amines are weaker than primary and secondary. Actually, when it is in aqueous point means it is less soluble in water. So less soluble in water in the sense there is no hydrogen atom. Hydrogen atom, it is very less when we comparatively talking about that secondary and primary. So in tertiary amine, it is alkyl group, it is more, that is bulky group, steric hindrance takes place. That is why. So plus, that is H plus ions, proton cannot reach to the nitrogen atom to accept the electron pair. So tertiary amines are weaker base than primary and secondary amines. So how can you write it? Secondary amine and then primary amine and then tertiary amine and finally ammonia. Okay, this is that you can write it. Okay, tertiary amines are stronger, that means secondary amines are stronger than primary amine, and according to this solubility part. Okay, secondary amine, primary amine and then tertiary amine. Why secondary amine? Just now I have told it is more number of alkyl groups are there. It is ready to push the electrons faster than primary amine. So naturally secondary amine is stronger than primary amine than tertiary amine because it is bulky group. And then see, more number of alkyl group also it's not good. Less number of alkyl group also it's not good. Hope you remember this. Okay, next one, ammonia. It is very less comparatively. These. See here, this is primary amine. This is primary amine. And this is secondary amine. And this is tertiary amine. What is the speciality in this means? It is a protonated amine. Hope you got it. Here NH3. Here actually what it is? Here in this. Here R not H. Only one R it is there. So here can you see? Yeah. Or NH2 in this protonated water molecule which is attached over there. So it is protonated primary amine. Okay, now this is secondary amine which is protonated here. This also water molecules. Two bulky group of what it is alkyl groups are there in this water molecule both the side. Okay, now wherever hydrogen is there in that place they are ready to attach with water molecules. So hydrogen bond and water molecules both are interconnected. Hope you remember those points. Okay, next third one, tertiary amines. In the tertiary amines hydrogen it is actually very less comparatively primary and secondary amines. So here only one water molecule it is available. So here protonated tertiary amine which is very less comparatively secondary and primary amine. In water, the amines or protonation undergo hydration formation of hydrogen bond. Higher number of hydrogen bonds formed with water, more stable should be protonated amine. So where it will be more stable means primary amine it will be more stable than secondary and tertiary. Okay, now actually protonated primary amines undergo maximum hydration due to small size. That is one point. Small size and maximum number of hydrogen bonding with water. So it is possible. Next, but tertiary amines or minimum number of hydrogen bonding is possible. Why? Because of hydration effect. That is hydration effect is very less in tertiary amine. So I'll give you a simple idea about this. Basic strength. Basic strength of amines, okay, depends on, I'll give you first point. First point, electron releasing group. Electron releasing. Electron releasing group of plus I effect. Okay, now second point, steric effect. These are all the points. Third point, hydration effect. Hydration effect is nothing, solubility test. Okay, now here I'll give you that idea. The electron releasing group, that is plus I effect, how that formation, primary amines are lesser than secondary amines are lesser than tertiary amines. So plus I effect, why? Because bulkier group pushing the electron, that releasing group of electrons, alkyl groups, it's ready to push the electrons of nitrogens or it is ready to donate the electrons. So primary amines are stronger than secondary amines are stronger than primary. Okay, so tertiary amines are strongest according to plus I effect. But in the steric hindrance, here primary amines are stronger than secondary amines are stronger than tertiary amines. Okay, now steric hindrance, where it will be more? naturally tertiary amines it will be more. Okay, now next hydration effect also here, which is primary amines, then secondary amines, here tertiary amines. Finally, basic strength. Basic strength. Basic strength which will be higher, secondary amines are stronger than primary amine and then tertiary amine. Primary amine and tertiary amine, and finally NH3. Hope you got all these points, which is stronger, which is weaker, why it is stronger, all those points it is coming in this video. Hope you got it. Enjoy this video and give the comment. Thanks for watching.